Hello again to this course about smart pointers. There is a lot of type of smart pointers, but in this course I'm going to talk about two main smart pointers that you should know and you should use in your C++ code. And both of them are features of C++11. Unique pointers and shared pointers. A lot of people are confused about using unique pointers or shared pointers when we should use one of them and not the other, how to use it and so on. All this question I'm going to answer it in this course. Um, just follow me to receive a new course, and if you have question, you just put it in the comments so I can answer it in the future video. um, as I said, smart pointers are so interesting um, because it handles some very interesting task in the background that normally you should handle by yourself. So smart pointers, we are going to answer all these questions. What is a smart pointer? What is a unique pointer? And what is a shared pointer? And when we should use one of them. Sometimes you should use unique pointer, and sometimes you need to use a shared pointer. The difference, I'm going to explain the difference between of them, and also I'm going to give you a very interesting example that show you the main difference between these two types of smart pointers. So what is a smart pointer? Is a typical way to create pointers with added functionalities. So in the last video I talked about pointers in general, basic pointer. Now we are going to talk about a smart pointer with other functionalities. It helps you to delegate some memory management tasks to the smart pointer template. What kinds of functionality? Counting reference and calling delete, for example. The syntax is so simple pointer, and you declare the data type and the name of the pointer, and you instantiate your data type. The syntax just differ from the type of smart pointer to another. For example, a unique pointer, you should use unique pointer, and for a shared pointer, you should use a shared pointer. Weak pointer also. But the syntax, it's quite the same. There is some differences in the C++ 14, using make ptr, but in general the syntax is working fine in C++ 11. So unique pointer is a smart pointer containing a unique row pointer. Own it. You have to know that unique pointer own the row pointer inside, so you can't copy it, or you can copy it or assign value to this pointer. But if you want to assign it to another pointer, you should move it, and when you move it, the basic and the source pointer is no longer available. So the syntax is unique pointer, data type, and the name of the pointer, and the new operator, and the data type. So as I said, the interesting things here is that you can't copy the row pointer inside the smart pointer. Uh, if you do that, you will have a compiler error, because it is not designed to be copied. So for shared PTR, it's the opposite. is a smart pointer maintaining reference, counting ownership of its contained pointer. So shared pointer is doing a lot of things, counting references, and you can copy the pointers, the row pointers inside, and it handles all all destroy functionalities about the copies. The syntax is the same as unique PTR, but here is we mentioned that we want a shared PTR instead of a unique pointer. So as I said, you can copy the row pointers inside the shared PTR, and this is the cases that and this is the difference between both of them. Use unique pointers uh, yeah, with unique pointers if you don't need row pointers copies, and use unique pointers if you don't need to save the source row pointers after memory move. This is so interesting. When you do a move, the older pointer is not available. Use shared pointer in case you need to copy pointers. This is so interesting. If you want to copy unique pointers, then you move it, and when you move it, the old one is not available, and if you point to the value, you cannot get the value. So I'm going to show you the examples about this interesting things. So uh, created just to zoom to pick to make it clear for you. Okay. uh, okay, so I created a program, so I can call it smart pointers, and I'm going to show you the difference, how to use it first, and the difference, and how to manage values inside the pointers. In this program, you can see the syntax as I mentioned above. Uh, for unique PTR, I mentioned that I want an unique PTR, and I want a pointer to point to the integer. So I should put an integer inside inside the inside the template parameters. Then I initialize it by 5. Here I show you, I print the address of the unique PTR and the value also. So for the unique PTR1, if I create, or if you try to create an unique PTR2, and you assign the PTR1, you will get a compiler error, because you cannot copy the unique PTR. And because also the copy constructor is deleted in the template implementation of the unique PTR. So the if you want unique PTR1 to assign it to the PTR3, you have to move it using a std move. So the whole memory address is transferred now to the PTR3. So if you try to access the unique PTR1, you cannot access, and you will get a null value in the address. So if I try now to get the address of ptr3, and the value of ptr3, I should get the same address as unique ptr1, because I move the memory address to the ptr3. So that's why I showed the ptr1 address, so you can see the null value. For shared ptr, it's the same thing, but you can, for example, I can move, for example, I can copy, for example, the ptr2 to ptr3, for example. Here I create a shared pointer ptr for integers, and here I create another shared ptr to an array of integers, 5 integers. So 5 allocation for an array. And when I assign the sptr 2 to the sptr 3 to the shared ptr 3, I can I can assign the value also. I can assign the value of shared ptr1 to the first element in the shared ptr3. So here you can see that I can assign ptrs, pointers, and I can assign values simply as a basic pointer. But for example, if I but the interesting things here to know is that now when I assign the splitter is shared ptr2 to ptr3, they have now the same address, and they are pointing in the same memory address, and they will have the same value. If I assign a value to, or for example, I assigned value of shared ptr1, which is 5, to the shared ptr 3, and I have the 5 also in the shared ptr 2. That means that shared ptr are just copies. When you assign a shared ptr to another, you are doing copies of the same address in the memory. And the opposite of the unique pointer, if you are doing the move, you will see the address of unique ptr1 is a null pointer. So to pay attention, you should to pay attention about moving pointers and doing copies. When you when you are doing when you move memories address, that means you make the old pointers uh, uh, you make the older address unavailable. So you have to use the new one. And for shared pointers, it's not a problem. You can assign values as you want, but you have to pay attention for the memory address, because both of them have the same address. And when you change the value pointed by this address, it will change the other one also, and will have the same address as you can see. For example, for the shared ptr 2 and 3, we changed the value of ptr3, and the other one changed it. Thank you for watching, and if you have question, put it in the comment.